So I'd like to welcome officially Mr. Ashraf Takla with Mixel.
Well, thank you, Sean. Um, so today I'm going to be talking about MIPI and the Mixel MIPI IP portfolio. So to make the presentation relevant, it would be great to find out who has ever heard of MIPI before or have some familiarity with MIPI. Okay, so most people don't know what MIPI is, so that hopefully will make it even more informative. So um, MIPI is a alliance of companies that was formed in 2003, so many years ago. Its focus originally was mobile platform, so the focus has been on developing standards that address the mobile platform. It has hundreds of member companies. Some of them are contributors, some are adopters. And the MIPI Alliance over the years have developed tens of standards to support the mobile platform. In the last maybe 6 years, because of the great success that MIPI has had within the mobile platform, a lot of adoption for cameras and displays, which are of course used heavily in the mobile platform. It started to be used outside mobile, and that is where a lot of the growth is coming from now. So this is just to familiarize you with the different market segments and the applications. So of course the biggest market segment is mobile. That's where it started. That's where most of the adoption is still today. A lot of upcoming application that is gaining a lot of traction, such as IoT, automotive, virtual reality, augmented reality, medical is starting to see some. In terms of the applications, many different applications, but the key applications, and that's what Mixel focus on, is interface with camera, display, and chip-to-chip communication. So Mixel is focused on the physical layer, the SerDes between the different components that support MIPI. So this is an example of a mobile system diagram. It shows all the different components that are typically used in a mobile platform. So of course, as you can see in the center, you have an application processor. You have cellular modem. You have Bluetooth, many different components. Of course, key here is the display in the upper left-hand corner and the camera next to it. So obviously, each mobile platform now has one or more of those. Then you also have, of course, quite a few chip-to-chip communication kind of interfaces. Mixel focus, as I said, on the physical layer for high-speed data transmission. So that is widely used for the CSI, which is the camera serial interface, camera application, DSI, which is the display serial interface for display application, and then the chip-to-chip communication. Through the years, there has been multiple phi standards, specification introduced by the MIPI Alliance. Currently, there are 3. The first one was d-phy, and that has the widest adoption in the industry. There is also a c-phy and an m-phy. So in this particular diagram, you see the c-phy and d-phy mostly used for display and camera. The m-phy is more used for chip-to-chip communication. This is a similar diagram, system diagram, but for automotive application. So the modern cars now, of course, has many cameras and many displays. Automotive electronics is a great growth area for semiconductors in general, and of course, MIPI is riding on that wave. So a lot of the penetration in the automotive industry with camera is very high with MIPI. Display is a second. You can see a typical car nowadays has between 4 and 8 cameras, and that is only growing to support the ADS, and which is autonomous driving system, and ADAS, which is advanced assisted driving systems. So this is an area where MIPI is showing a lot of adoption, and of course this is only a few pieces of the many things that the MIPI specification is used in the automotive applications. Now let me tell you a little bit about Mixel and MIPI. So Mixel has been a member of the MIPI Alliance since 2006. We have been very active, focused on MIPI applications, specifically the physical layer. We are the first to silicon prove the d-phy, c-phy, and m-phy. So we support all the MIPI phys. We also have a platform FPGA support so that our controllers and the phi can also be integrated with a FPGA to support the customer's requirement. We believe we have a differentiated solution in terms of power and area features, different configurations. We believe we have the largest share of the market. We have over 85 licensees, MIPI licensees. We have wide coverage of the different foundries and nodes. And we also have developed a alliance of companies that support our MIPI customers from the different requirements, such, of course, the phi, the controller, the VIP, the testing, test equipment manufacturer, labs that support MIPI, systems, and that enable the customer to get all they need to go to production very quickly. I'll tell you a little bit about the different phys. So the widest adopted phi is the first phi, which is the d-phy. The d-phy is a very unique phi in the sense that it supports two different modes of operation. One is high speed, which is LVDS type, but it also supports low power operation. As you can imagine, the most important thing for mobile application is the power. So the focus is always about reducing the system power. So the low power operation was included for that reason, which means that you need both a high-speed transmitter, low-power transmitter, high-speed receiver, low-power receiver. This is a half-duplex system, so you have the information flowing both direction, not simultaneously, so you need a contention detector. Then, of course, you have serializer, and you have logic RTL that is needed to enable the system to switch back and forth between the two modes of operation. So we have, as I mentioned, the platform that support this. We provide all the IPs needed, the phi, the controller, and the platform. The platform consists of a daughter card that integrates the Mixel test chip, and then off-the-shelf FPGA that can incorporate the RTL, our RTL as well as potentially the customer's RTL if they want to customize it for that particular application. This particular this is one lane out of many lanes that can be used, that is used for the transmission. So typically you would have one clock lane and multiple data lane. So this is one instantiation, one lane. So the typical phi would have one clock and multiple data lanes. So because of that, and because the area of the IP, because it has many different transmitters and receiver, of course, it's very important to minimize it. So through the year, we came with different configuration that optimizes for certain applications, specifically for a receiver. You don't need the transmitter, the high-speed transmitter. So, but you need it if you want to do full speed loop-back test of the IP, which of course testability is becoming very important. So this particular configuration uses one transmitter with many receiver to be able to do the full speed loop back without the additional area of the other transmitters. So this results in 35% reduction in area, about 50% reduction in the power dissipation, leakage power dissipation. This is very important for automotive application because, as you can imagine, testability is key for automotive safety testability. Full speed testing is important. You need to do that on a production test. You need to be able to do that in system. So while the chip is in system, to be able to do diagnostic. So this particular IP has been used at different nodes, 55, 40, and 28.